again. We're ready to get started up now. Continuing on with the microservices theme, Yasha Podeswa from Hootsuite is going to talk about a data-oriented pipeline that's got some microservices aspects to it as well. So,
thanks. Cool. So yeah, as Terry mentioned, I'm from Hootsuite. So if you're here for Adam's talk this morning, same company. So yeah, just a little background about me first. I don't come from a traditional comp sci background. I actually used to be an oceanographer. There's me canoeing around the ocean and just like sorting through seaweed and stuff. I kind of decided at one point that I really liked the data analytics and scientific computing aspect, but not so much all of the dissecting shrimp all day. So I kind of switched into data analysis, and from there, really liked the computing side and got into software development. Yeah, so I'm a software developer at Hootsuite. We build dashboards like this, kind of social communication tools. So if you have a business and you want to reach out to all of your followers on Twitter, Facebook, LinkedIn, maybe talk about the nice new coffee you have coming out, you can do that through Hootsuite. You can kind of triage their responses as they come in. You can analyze which campaigns are most effective. So at Hootsuite, I actually work on an internal team. So we build software to help everyone else at Hootsuite make data-driven decisions. So if you are on a marketing team, for example, you want to know how our marketing campaign went, we would help you with that. Or if you're on a product team and you want to know, we just put out this new feature, is it working? We'd help you with that too. So any other BI developers in the crowd? All right, so just you will be calling me out on my bullshit, which is good. Cool, so this talk, we're going to first introduce a problem that would require a new data pipeline. And then we're going to talk about how we would design it and maybe how we would steal some ideas from service-oriented architecture to make this pipeline really kind of reusable and well-organized, and talk about some of the design decisions and trade-offs. And finally, we're actually going to build it on stage. So most of this will actually be a live coding demo. Not going to build the entire thing, but some really key pieces of it. Cool, so the problem, we've got this huge emergency at our company. One of our biggest clients has just left, and everyone's freaking out. There's meetings all over the place. They're giving us tons of money. They're gone. And our friend here, Desperate Dan, he's in real trouble. It was his job to make sure this company does not leave. He's an account manager. So yeah, his job is to make sure that all of our accounts stay happy and continue to pay us, ideally. So what happened here, though, is Desperate Dan feels like he was really blindsided. The customer was saying, oh, yeah, we're doing fine. We like the tool. We're using it. But it turns out that in their kind of exit interview, they told him, actually, we just couldn't be bothered talking to you. We never really onboarded with the tool. It didn't get adopted. And Desperate Dan had no idea. So he thought everything was going smoothly, but in fact, this huge account was not really using the tool and was at a big risk of churn. And he should have been in there reaching out to them and making sure they were happy and getting onboarded with the tool. So Desperate Dan comes to us and he says, hey, you need to give me some insight into how people are using the product. So really, he wants something like this. A tool where he can go in, see all of the different Hootsuite accounts, maybe rank by how much they're paying. He should be able to filter down to just his account. And then, when he filters down to just his account, he could filter down to a specific organization and see all of their activity, how many messages they're sending, how often they're logging in, filing support tickets, and get an idea of the health of the business. Are they filing more tickets over time or less? We say that sounds great, but we're pretty busy. I don't know if we have time to build this. But Desperate Dan, being kind of a salesperson, knows our weakness, which is craft beer for me. So he bribes us, and we say, all right, let's do it. Cool, so we want to build this nice dashboard for Desperate Dan, but all we're really starting with is this kind of event log data. So we've got, if you look here, the first event there, it looks like someone was scrolling a Twitter stream. That's like something that a user was doing. The second event, it was a payment for a fair bit of money. And the third event is just some crap. So we've got like, who knows, maybe someone's trying to SQL inject us. Maybe it's our security team doing random penetration testing, but we get events like this that are kind of just garbage. So we know we've got this kind of log data, and at a very high level plan for our app, we've got our JSON files. We just want to calculate some stats about the organizations, load them into a data warehouse, and use this to power our dashboard for Dan. So if you've heard of like an extract, transform, load process, it's basically just that. So Dan's psyched. He says, all right, let's get on it. Let's build this thing. I'll give you like all the beer in the world if you build this for me. Let's do it fast. But there's one thing we're a little bit worried about, and it's that big calculate stat step. Everything's happening in one large step, and we're kind of doing two things at once, really. We're getting all this log data, we're reading it in, cleaning it up, and kind of organizing it. And then from that, we're also calculating stats about organizations. The problem with doing this all in one big step is that if anything else wants to start using this kind of cleaned up log data, either we have to keep on pushing more functionality into the same app, or it has to kind of repeat the logic. So what we're going to do is just separate this out into two small apps. One app that is going to be the only one that ever deals with the raw log data and does all the cleaning and sorting, and a separate app, in this case, that calculates stats per organization. So that's useful for lots of things. It's going to give us a single source of truth. So anytime we want to work with this kind of log data, we're going to have it all kind of pre-sorted and pre-cleaned, and we're only going to have to run that job once. And then this organization stats job, we just want to make sure that it doesn't run, obviously, until the previous job is done. So we're starting to see, though, that, all right, we've got these two jobs. We need to have a way to set up dependencies between them. And there's probably a whole bunch of other niceties around them we'd want. So monitoring, emails in the middle of the night when a job fails. We'd want to know if jobs are taking longer or shorter than normal. We'd want to have retry logic. A lot of these ETL jobs you'll build in data pipelines, you're relying on external vendors. Sometimes their APIs will just be down. So sometimes it's just a very good strategy to retry a fail job. So everything around retrying, setting up dependencies, we'd like to have that kind of handled for us and not have to build that into every single app. So really, we need something kind of similar to like a service communication and orchestration layer. If you saw Adam's talk showing all the dependencies between apps and being able to see when one app is down, what that's affecting, that's something that we need to. So at Hootsuite, what we use for this is a tool called Airflow. It's an open source tool from Airbnb. And up here you can see is kind of a dependency graph showing all the way at the right is a job that kind of, it's a machine learning job that predicts which users are at the highest risk of leaving, churning. But that obviously depends on a lot of different data. And all those other jobs that it depends on are generally useful for many things. So by putting all of this dependency, retry, and kind of communication logic into Airflow, it keeps the individual apps very, very simple, which is nice. Kind of the same goal you would go for with like a microservice. And it also it lets us hook things together in a really nice way where if one of the apps on the left fails and it affects a lot on the right, you're not scrambling to kind of deal with bad data. Before we ran everything just with cron jobs, and when an app on the left fails, especially if it failed kind of partway through, it might have some data and other apps are calculating statistics and using that data, but it's incomplete and it's kind of corrupt and you'd have to be tracing down what all the dependencies are. Airflow will retry things and it just won't run the next step until all of its dependencies have run successfully. So it's a big win for maintainability for us. All right, so that's kind of the basic idea. Let's get into some code and actually build this thing. So we're going to be building, again, 3 little components here. One is the event cleaning and loading app. A second component is this app that, with the cleaned events, is going to calculate statistics about each organization. And then finally, we're going to implement Airbnb's Airflow tool, and we are going to hook up our dependencies and have the whole thing run. So yeah, the first app is this event loading app. Again, takes data from S3, cleans and sorts them, loads them into a data warehouse. It's just going to be a vanilla Scala app. So do we have any people who've written Scala in the crowd? Cool. Cool. I got a couple. I'll go over some of the key points and kind of describe the code as we go. And finally, we're going to deploy this to AWS Lambda. So Lambda is a service provided by Amazon Web Services. The idea is you kind of just put a function in the cloud. You don't have to maintain any servers. It's dirt cheap. You only pay for what you use, which is really, really nice. It's kind of a good fit for jobs that run infrequently as opposed to all the time. So that's perfect for our batch jobs. There are some downsides. There's only limited language support, so you can only do things in JVM languages, Python or Node, which is fine for us because we're going to use Scala. I like Scala. And then other issues are 1.5 gigabytes is the maximum amount of memory consumption you can have during your job. So that's pretty limiting for data jobs, so we have to often be pretty conscious of not having too much data loaded into memory at once. It also has a 5-minute maximum runtime, so if we're doing a lot of async I/O, if we're doing a lot of I/O, we probably have to do it asynchronously. Otherwise, if we're processing a lot of data, we can easily exceed that 5-minute runtime. So I think it could be an awesome product for data processing jobs if they up some of these limits. As it is, it's really good for certain jobs, but it's not like a generally applicable for all jobs. All right, so we'll jump into the code. There you go. Okay, so the first thing we're going to look at here is the main body of our event loading app. There's just this handle request function that we have to implement for Lambda, which is basically going to run our pipeline and then return a response, success or failure. One key thing to note here is Lambda will sometimes start up your whole app and run it, or will sometimes keep it going and just recall the same function. So kind of cleanup that we would do, anything stateful, you have to be very conscious of this. In this case, if we were to close our database connection within the app itself, that would cause problems when Lambda decides to just run the function a second time. So yeah, we're going to jump into the main body of the code here, this pipeline run. Cool, so all this does is it gets files from S3, and then it processes them. A nice thing here is anyone familiar with the concept of like futures and promises? We're going to use those here. So in Scala, the idea is you might have some kind of a computation you want to do that's really slow. So this is kind of like slow computation. You can wrap this in a future. And what you get back is an object that you can register callbacks with. So you can sort of map over the future and do things to what's inside the future, and that won't run, it's just like a standard callback. Another nice thing is you can pass in a specific execution context that the future will use. So this is a really good way that we can make sure we don't have too much memory consumption in our Lambda app. This execution context is backed by a thread pool. So say, we're going to be pulling in little bits of data at a time. By tweaking the size of the thread pool and pulling it all in with the same thread pool, we can basically just configure the size of the thread pool, which will configure our level of, how kind of async we're going, and that will allow us to limit how much data we're bringing into memory at once. So our pipeline run here, is going to all run in the future. And furthermore, this process files we can see itself returns a future. So what we need to do here is read a file, extract events out of that file, and then load those events into our data warehouse. And we also, when we get the files from S3, we could have loaded them straight into memory, but then it would have been hard to avoid having too much data in memory. We're going to write them to a file, even though it's slightly slower, and then kind of process them maybe just a few at a time afterwards. So first, we've got this file. Let's get all the data out of the file. So we'll just get the lines, and we'll just turn that into a list instead of, I think it's kind of an iterator. Then what we need to do is once we've got all these lines here, so this here is going to be a list of strings. We're just going to turn that into JSON lines. So we're going to parse it into sort of like a JSON ASD. So we'll just map over those lines. And for each one, we're just going to apply the JSON parse function to a JSON line. So now we've got just this little list of JSON. Now what we want to do is take all of the different types of JSON in there, extract all the different types of events, and then load them into a database. So first we're going to extract the events. Cool. So then we've already got this little function here that lets us extract events. So maybe let's jump into that and see what's going on there. So the extract events is going to take a sequence of JSON, and we want to turn it into this kind of extracted events. And we can see here we've got this other method here that we're going to implement to extract an individual event. So maybe we'll implement this method first. We've got some JSON, and then we want to basically see if it is a user event. And we've just written some code elsewhere that basically will let us know how to do this validation. So if it kind of validates as a user event, we will just return that user event. However, it might be something else other than a user event. So if it's something else, we're basically just going to repeat this pattern. Next, we'll check if it's maybe like an organization payment. And then again, we'll match on that, and we'll see what class it is. So Scala has this matching that's popular in a lot of languages now, where you can kind of decompose a class, and you can see what it is, as well as get at values within the class. So if it's an org payment, we'll just return that org payment, and then we'll just repeat this pattern some more. If it's an org event, return it. But then we need some kind of a catch-all. We don't want to just throw away all of that garbage data from security, because it's also possible that it's not really garbage data. It's just new kinds of legitimate log data. So we'd like to store that somewhere and have monitoring on that, see what kind of data is coming through, and if we were throwing stuff out by mistake, be able to recover it. So we're going to validate and see if it's an unknown event. And then the way that we've written this validation is basically that anything can validate into an unknown event. We basically just grab the blob, we maybe like hash it to get a primary key for the event, and we're going to save that somewhere. But This is normally kind of an unsafe operation. Very often in Scala, get on almost anything is unsafe. But because we've made it so that it will always be a success, we can just go ahead and get it. Cool, so now we can give this function an individual JS value, and we can extract it into either an org payment, a user event, an org event, or an unknown event. So given a sequence of these events, we could just extract them pretty easily. By calling extract event on all of them. This is really just the, Scala has these case classes, which are just really like a little container for data, and they don't have their own individual type, but they look kind of like this. Now out of this, we need to go ahead and, if we look at our extracted events, it's just a container for a sequence of all the other types of events. So we want to go and just collect out of these events each of the different types. And then once we get those, what we want to do is upsert those into, well, we'll just collect them first. So we're going to return an extracted events. Its first argument is just some user events. This is kind of like you can use it like a filter on types. So we're just, if it's a user event, we're going to return that. And likewise, going to do the same and just collect all of the organization payments, organization events, and unknown events. Cool. All right, so I think that's really it for the extractor. However, if you remember before, we were using the extractor to extract all of our JSON, turn them into kind of known case classes, but then we wanted to upsert them. Cool. Sorry, it's going back to the wrong project. I'm just going to exit presentation mode here for a second. So we've got our extractor. It's all implemented now. If we just go back to this pipeline, oh, I got it. Cool. So we've got all of our extracted events. Now we just need to upsert these all. And again, we want to make sure that we don't have too many in memory at once. Going to get our user event DAO, and we're going to upsert the user events. And we'll just do the same here for our org payment. Our org events, and finally our unknown events. We have to use the appropriate DAO. And it's very important that this upstart operation, that is itself returning a future, and it's important that that kind of have its own thread pool from the rest of the application, so that we can kind of bulkhead a bit and make sure that other things happening in the application aren't preventing the data from basically getting out of memory. So once we've got all of these are again just themselves all going to be futures with the number of events loaded. So we still just have callbacks here, and they're all kind of processing separately. So we can use this tool future.sequence, which takes a sequence of futures, these kind of callback objects, and returns a future of sequence. So sequence of future to future of sequence. Then we have a single callback that's kind of waiting for them all to be done. And then finally, we just want to know the total number of records loaded. So that should give it to us. This is, again, just a callback on the future itself. Cool, so this whole thing should be done now. So let's try here. We got, start up our little build tool. And fingers crossed I didn't screw anything up too badly in there. See if it still compiles. And then we just set it up as a little command line app. So we can run it for a specific day's worth of events. In Lambda, we would pass this in. We would instead of calling from the command line, we would basically just make a request with the JSON payload, again, for a specific run date. Cool, so that's done. I'm just going to run this little build and deploy script, and that will deploy it up to Lambda so we can run it from kind of in the cloud. While that's going on, we're just going to here work on our organization stats app. So this app here this organization stats app, pretty similar to the last one. The last one cleaned and loaded data. This one is going to read from the data warehouse, get the output of the cleaning and loading app, calculate stats about an org, load them to a data warehouse. And again, it's just going to be a vanilla Scala app running on Lambda, so all of the same kind of limitations and considerations. So this app is structured in very much the same way. We've got a pipeline that we run, and we run that pipeline. So we're just going to implement the run function. So what we want to do here is we want to get all of the orgs, then get stats for each organization, and then save those stats to a data warehouse. So first we need to get all the orgs. So we need to get some org IDs. We're going to get all the orgs. At this point, we've got like a future sequence of organizations. So the mapping, now we're down to the level of the sequence of organizations, and this will just run as a callback when this is done. And then we have a sequence of organizations now, so over each one of those, we're going to map over each organization in the sequence and just get its, too many maps. Just get each org's organization ID. So now we should have like a sequence of these org IDs. Now we want to get the stats for each org. So again, here we're working on the org IDs, and we're going to do something that returns a feature itself. So mapping would be working just on the inside. Flat mapping will kind of unwrap it. So we're going to get all of our org IDs. We're going to map over those. And for each org ID, we will get org stats about that org ID for a specific run date. Again, IO going to a future. And we're going to then flat map this with our going to upsert those. Finally, if we look at what this is, we're doing this for every single org ID. So we've again got this kind of sequence of futures of the number of records loaded. And then here we would end up with a future sequence of ints, and then we'll just sum those all up, get the number of records loaded. Again, the nice thing here, because this is all being done kind of on the same thread pool, we can rate limit a bit. And another really nice aspect here is we've got kind of two different DAOs. We've got things that are reading data and things that are writing data. We want to make sure that they don't block each other. We don't want the writers to we don't want all the readers to basically block the writers from being able to write and kind of release the data from memory. So we've got this little object graph, and we use one connection pool for all of our readers. This is where we created all of our DAOs, and a separate connection pool for all of our writers. Cool. So let's try running this app. So our previous one looks like it compiled and uploaded to Lambda just fine. One of the worst parts about Scala is the loading time for SPT, which is its build tool. We'll run our tests. Looks like they're all good. Let's try running it for a random day. Cool. That looks like it worked too. We're also just going to run our little build and deploy script here. Obviously, you probably have something better than this in prod. But finally, we're just going to jump into our Airflow code here. So the Airflow code is really, really simple. We're using, it's kind of magic framework, does a lot of reflection and crazy stuff. But we basically just declare a graph that all of our nodes are going to be a part of. We have one node that just makes sure that our data is already in S3 for us to work on. We have another node that is going to run our event loading app, which is the first one we worked on. And our third node that will run the organization stats app. And we've kind of in these default args configured retries and everything else like that. So all we really have to do is declare our dependencies between nodes. So we're going to take our event loading app and set an upstream dependency on this S3 sensor, waiting for its data to be there. We'll take our org stats app and set an upstream dependency on the the event loading app. And that's really it. So right now, if we go and load some data into S3, it should kick off these jobs automatically through Airflow. So let's try doing that. So we're going to load some data into S3. And if we jump into Airflow, this is the UI for what I was showing you before. We can see our runs for each individual day. For example, on the 29th, everything completed successfully. Now on the 30th, the sensor it found the apps. This is running. Go into our logs, see it all running. There we go, and we got a success there. And now our ETL org stats app is running. And obviously, with just 3 apps, it seems a little overkill, but once you start to get a huge graph, having all these kind of dependencies and communication layer is really, really key. Another really huge point for us is that in this dependency graph, we are really not limited to what each dependency is. So lots of data pipelines will be built on very heavyweight frameworks that will help you do all of your jobs, but you kind of have to do them all in one language following one kind of convention. In this case, some of our jobs are like Spark jobs, processing huge volumes of data. Some of them are just like quick little scripts that were written ages ago, but that are still working, and when we haven't had to get rid of them, we've got a couple shell scripts in there. Lots of them are Scala and Python little jobs. We can have machine learning jobs written by, even in something like R, written by our data scientists that we can plug into the pipeline. So it's very, very, very flexible. We also do a lot of real-time data processing. That doesn't fit so well it doesn't really make sense to have Airflow run that. It's really for running batch jobs. But if we have other jobs that depend on this real-time data processing, Airflow is great because it lets us say, only if our whole kind of event logging pipeline that uses Kinesis is actually up and healthy, should we run the dependent batch jobs. And so it lets us really stitch together our real-time processing and our batch processing. And we can see here, all of our jobs are done now. And I've just pre-built a little dashboard in Tableau that connects to the data warehouse and will let us visualize all of this for Desperate Dan, our friend, and then we can get our beer, he can stop losing clients, everyone can be happy. Oh, shit. Log me out. Nobody look. There's nothing very valuable in here, but there we go. So I don't know, the resolution's a little weird. I don't know how well I can zoom here, but we can see we can now can see all the stats. We can look at just Desperate Dan stats. You can filter down to an individual company, and you can go ahead and see, how much they're posting, like how many messages messages sent in the past month. This is a really high-paying company. Maybe he sees that they've kind of stopped posting to LinkedIn and to Instagram, and they've only got like 1 login in the past week, so that's like danger zone, and he's got to go reach out to them and kind of get them engaged again. So yeah, that's really it. all this code, if you're building a data pipeline, it's meant to be kind of a demonstrative starter project. It's all on GitHub, so feel free to go and steal it or critique it or whatever. And yeah, any questions about the presentation or about just how we do data pipelines at Hootsuite? That's it.
I guess the question is, what's the JSON files you're taking? You could also be doing this in a more traditional ETL process to load them, and probably because a lot of this with Scala is all very new to me. But what's the big advantage in your company to doing this approach as opposed to more traditional, monolithic ETL, into a relational database, and then running Tableau against that?
Yeah, so we still end up in a relational database. We use Redshift. It's like a very good sort of analytical database. But we really like to, instead of doing everything in one step, that would kind of be often a classic approach is to just take the files and, you get your output. We did start doing that, and things naturally get very coupled, and either you repeat the same logic in different jobs, like around the cleaning and loading of events, for example, or you just have this like really, really huge project that gets very cumbersome, and suddenly you're doing everything in that project, and then you realize on that project, you're just doing it on classic servers, and you need some kind of cluster because you have so much data now. You need to start having some Spark jobs. How are those all going to fit together? How is your real-time processing going to fit in? So for us, using a much lighter weight framework like Airflow that just does communication and tries to impose no logic about the jobs, and keeping every individual job very small, it lets us have kind of a single source of truth and only do each job in one little spot and stitch it all together into a nice big whole where each app is pretty simple.
All right, thanks.
Yeah.
So I looked at your presentation, and there are multiple steps. And what sort of monitoring do you do for each step? Do you proactively monitor, or have some sort of graphite or something where you push metrics and constantly try to keep alerts and try to fix the pipeline if it's broken?
Yeah, so Airflow actually, we use Airflow for kind of all of that. So Airflow, we have it configured to send alerts to us whenever jobs fail. You can also, I can't see it now, but within Airflow, you can monitor job runtimes. You can really get a lot of insight into the jobs. All the logs are in one place there for all the jobs. So it's a really, really nice kind of solution to keep on top of everything. And before we were using cron, so we had lots of, not every night jobs fail, but almost every night, just because there's so many of them. And when they did fail without the retries and without all these dependencies mappings, it was a real pain in the ass in the morning to kind of get the data right. Having this whole layer on top of it has really helped. And we had some kind of dependency logic built into the jobs. Now that can all be stripped out and they can be kept very simple.
And how would you, I'm pretty familiar with Spark streaming, which also kind of breaks it down into multiple steps and run code. So how is this approach, is this one and the same, or is this different from that Spark streaming approach?
I actually haven't used, we use Spark a bit, but not Spark streaming. So it's hard for me to give a great answer, but a big difference would be, I think in Spark streaming, you'd have to do everything within that one platform. Right. Here you can, if you feel that certain technologies are useful for different steps and the best fit, you can use whatever you want.
Thank you.
So this approach implements the batch jobs that are scheduled at certain times, right? Mm-hmm. How would you implement it differently if you were to process a stream of events rather than a batch job?
Yeah, so we do quite a bit of stream processing too. The batch jobs, some jobs are just a natural fit for batch jobs. In the kind of BI space, people don't care about quite as much immediacy often, so it can be a little simpler. But all of the data, all of our initial product data, we do kind of process in real time, and we do a fair bit of stream processing on that. For that, we use Kinesis. So we kind of write to Amazon Kinesis, which if you've used Kafka, it's very similar to a hosted version of that. kind of like a message queue with different topics that can contain different types of messages. And we have little Scala apps that process from that in real time and kind of augment the data loaded elsewhere. Lots of jobs, a lot of the batch jobs depend on our streaming jobs. The streaming jobs might, write the data to a place like S3, and then the batch jobs pick it up from there. And then we stitch that all together using Airflow. Any more questions? No. Thank you guys very much for your time.
Thank you, Yasha. It's lunchtime now. Lunch will be served one floor underneath of us, so just head down the stairs or down the elevator. We will be back here at 1:30 for the next session, so we'll see you then.